work with logarithms. This is going to be your first introduction into the world of logarithms. They were invented in the, I'm going to say 1600s, I'm probably wrong, it might be 1700s. A guy named James Napier came up with them. Anyway, a logarithm is just a way of writing a really big number as 10 to a power or as e to a power. 10 is the number 10, obviously. It's the one that you grew up with. When somebody said back in kindergarten, count to 10, that's the 10 they're talking about. Back in kindergarten, you did not count to e, and at this point, I'm not going to make you do that either. But e is a number whose official definition is the limit as x approaches infinity of 1 plus 1 over x to the x power. That's what e is. You don't have to even know what that means, but just know that this number e is approximately 2.718281828. Looks repeating, right? 46. All right, but it does repeat. All of a sudden, it just stops repeating for whatever reason. It just goes haywire. It's much like pi. It's a transcendental number. It occurs in nature. It's a naturally occurring number. It was discovered. It was not made. And pi, if you look, pi is 3.14159265358. All right. It's just one of these irrational numbers that has special meaning in math. And e is going to be really helpful in financial situations. So when we're doing financial stuff, towards the end of this year and next year we'll do some financial stuff. We use e quite a bit when we're dealing with compounding interest problems, that kind of stuff. So, and that's logarithms happen a lot in compounding interest problems. That idea, and also in pH. That's where logarithms show up. pH, earthquake intensities of logarithms, things like that. So we'll be using this stuff down the road, but today we're just going to kind of get our feet wet and understand what logarithms are. So log is log base 10, ln is natural log base e. And those are the two bases we're going to be dealing with. We will not do logs in different bases as of yet. All right. If you take a look at example 1, y equals 4,302, find log y. So let me just show you stuff here. So this is log of 4,302, right? Now, I just introduced you to the idea of logarithms, and I said log and natural log, right? And you got two buttons on your calculator. Log is log base 10, and ln is log base e. And all of a sudden they give us a problem that doesn't have a base on it. Just says log, doesn't give us a base. All right? The way this is read is log of 4,302, understood base 10. When you see log and there is no base, it's understood to be base 10. When you see log base e, that's the same as ln. That's how they usually write it there, ln, with no base written. ln is natural log. Log is log base 10. Unless there's another base written, that's what the two bases are going to be working on. So they want us to do that. So y is equal to this number, find log of y, log of 4,302 base 10. All you got to do to find log of 4,302 is type in your calculator, log 4,302 equals, and it spits out the answer. 3.633670406. That's the answer. Let me get you to understand what that means. Because again, I can type anything in my calculator, it equals, and spits out an answer, I write it down. If I don't know what that answer means, I'm not understanding what my purpose is. So when you're finding log of 4,302, you're finding 10 raised to this power equals that number. That's what that means. So if I did 10 to the 3.633670406 power, it's going to approximately equal 4,302. I put approximately because that is a rounded answer. So if I try that out real quick, 10 caret let's type the right number, 3.633670406, and it equals 4,301.9999999. Almost 4,302. Again, this is rounded, so that's not exact. That's not exact. It's pretty close. That's all you're finding. When you're doing log base 10 of whatever, you're getting 10 to this power equals that. The answer to the log problem is the power, but just know that's what that power represents.